Let's look at rotational kinematics. So first thing is we will derive the first equation of, we'll start with derivation of first equation of rotational motion. Okay, so I'm calling rotational motion as Rm. So our assumption for all is that we are looking at rigid body rotating about a fixed axis with a constant angular acceleration. Okay, so this is constant. Right, so first thing is we can start off with our, okay, let me start off and then I'll show you guys. So we have angular acceleration alpha is equivalent to what? So we can write alpha as d omega by dt, right? Then same set of steps actually. I'm multiplying and dividing with d theta. So you can see that mathematically they are equal. Now d theta by dt is what? Omega. Okay, again, you guys have to revise the angular of all of those, angular acceleration, and which chapter was that? I forgot. Name I forgot. So you guys have to revise and come back. Only then this will make sense or it'll be easy. Now what should I do? Yes, we need to integrate. So integrating, sorry. Integrating both sides. Sorry. With t at t is equal to 0. You have theta is equal to 0 and omega, I'll take it as omega naught. And for t is equal to, after some time t, right, after t seconds, we have theta is equal to theta, okay, and omega is equal to omega. So now alpha integration of 0 theta d theta. Why is alpha out? Yes, it's constant. Omega naught omega, omega d omega. So while omega is changing, right, it's accelerating, right? So this is theta and this will be omega square by 2 omega naught omega. So if I rearrange and all of that, honestly, I'm skipping a step or two. You'll end up with this expression. And you can see it's equivalent to v square is equal to u square plus 2as. There are a lot of overlaps, as in when you will see. Then we have the second equation. Now we know that angular velocity is given by, if you guys remember the equations of motion, it's similar to those, the way we approach. So angular velocity is rate of change of angle, sorry, not angular, rate of change of angle with respect to time, right? So we have omega is equal to d theta by dt. Now again, we'll assume few things. Let at t is equal to 0, theta b is equal to 0, and at t is equal to t, theta b equal to theta. So with this, I'm going to integrate with respect to time. Okay. So first thing is I'll rearrange this. So I can read this as d theta is equal to omega dt, right? So if I do that, then I end up with 0 to theta d theta, and this is 0 to t. Remember, omega is changing. Now we have to substitute omega as omega naught plus alpha t, because omega and dt, the omega is changing, and how it's changing in this manner. So integrating this is quite simple because we have t as the variable. Since it has to be a single variable, so we have to express omega in terms of t, and we can do it with this, right, with this expression. So t omega naught plus alpha t dt, right guys? So if I open up the integration, this is theta, that's done. This is omega t integration of dt, and this is alpha t dt. So this is theta is equal to omega naught. Again, 0 to t I'm not writing over there. So this is t plus 1 by 2 alpha t square actually. This is similar to s is equal to ut plus half a t square, right? So you can see it's a similar set of things. So actually this is first, that is second, and this is third. But anyways. Now finally we have the very first thing, first equation. Consider a body rotating about a fixed axis. So, okay, fixed axis with constant acceleration. Oh, this already we already written this, but we need it for this statement actually. Now, let at t is equal to 0, omega be equal to omega naught. At t is equal to t, omega be equal to omega. Okay, so now we are going to integrate. On both sides. So we have omega naught omega d omega is equal to alpha 0 to t. Again, I'm rearranging and I'm not showing the step. So basically I'm rewriting this as d omega is equal to alpha dt. Okay, so I'm integrating this way. So when I integrate, I'll end up with omega minus omega naught over here, and here I'll end up with alpha t. Again, post substitution and everything. So that steps is left to you guys to show. Omega naught plus alpha t. How does it look like? Yes, v is equal to u plus at. So clearly there are similarities. So if you guys keep this in mind, you're pretty much done. I'm sure most of you would be familiar with all of this. But yeah, it's my duty to show you guys from my end. Again, this is second technically, and this is third. And this is supposed to be first, generally as per the books.